Welcome to page 8 of your probability packet, Sampling a Population. You should be on lesson 1.8. When you want to study a large group of people, that group is called a population. Now, whether you're collecting data or surveying that large group of people, you can't always talk to every member of the population. So rather than talking to everybody, you can take a sample or a sampling of that group, and if you do a good job selecting a nice mix of the population, you can get a representative sample of that larger group. So in other words, you study the smaller group in order to make predictions and conclusions about the larger group called the population. Let's read together. A random sampling of a population is only valid if every member of the population has a chance of being selected. That's key. A random sample of a large enough group generally gives a valid prediction about the population from which it is drawn. Data gathered from a valid random sample can only be used to make predictions about the population. Now, let's take a look at the rectangle below. Think of it this way. The rectangle represents the overall population I would like to survey. Imagine for a moment our population is all the students at Washington Middle School. That's about 500 students. And I would like to ask them a question. What should the new mascot be for Washington Middle School? We know it's the lobo, and we love the lobo. But just for the sake of this question, let's pretend we're offering them 3 options: an owl, a bear, and an eagle. Now imagine all 500 names floating around inside this rectangle. I don't have the time or the energy to talk to all 500 students. So what I'd like to do is take a nice random sample of those 500 students. I have the ability to talk to about 50 of those students. But when I select those names, I have to make sure that every member of the population is represented. If I grab 50 names and make sure that every person in the population has a chance of being selected when I grab those 50 names, I am selecting a random sample. That sample, if selected correctly, will give me the information I need to make a prediction about the larger group, the population. A good random sample should reflect what the population is thinking. So instead of talking to 500 students, I can talk to 50 and still come up with the information I need. Let's sketch a quick table off to the side. Break it into 2 columns. One for the information I gather from the sample, and 2, the second column should read population. And then our choices. Students can vote for an owl, a bear, or an eagle. Remember, we're only sampling 50 students total, but the information we get from those 50 students should reflect the opinions of the population, which the total population is 500 total. If you think about it, 500 divided by 50 equals 10. That means that the population is 10 times greater than the random sample. That should also be true for the votes that we collect in each category. What's true for the sample should be true for the population, except 10 times greater. So here we go. Take a moment, pause the video, and record the table if you haven't done so already. The votes were counted from the sample group. 10 people voted for the owl, 25 people voted for the bear, and 15 voted for the eagle. That's for the sample, the random sample. So what should be true, because this is a proportional relationship, is each category should be 10 times greater for the population. So if we were to talk to the entire population, we should get 10 times 10. We should get 100 votes for the owl. Then 25 times 10 means we should get 250 votes for the bear. And once again, the eagle, let's multiply it by 10. 15 times 10 is 150 votes for the eagle. And if you add up these three amounts, you get 500. If the sampling is done correctly and every member of the population has a chance of being selected in the sample, then what's true for the sample will be true for the population. This is how we can make predictions about a larger group based on just a small bit of information. As long as the sample is properly collected and every member of the population has a chance of being selected, we can make the kind of predictions we just did. Clearly, the bear would be the most popular mascot. However, I think the Lobo is the best. So let's stick with the Lobo. Let's look at the bottom of our page and see, what does it really take to be a true random sample? Well, remember, according to the definition, every member of the population, the larger group, has to have a chance of being selected. And in our rectangle, if you look at it, you have to remember there are 5th graders, 6th graders, 7th graders floating around in here. Boys and girls. Band members, people not in the band. Think of all the people in our building. Whenever you take a random sample, everybody has to have a chance of being selected. Let's look at the cases below and determine if it is a good way to sample or a bad way. So, we're trying to decide what the new mascot should be for Washington Middle School. Is it a random sample if we survey 50 students from the football team? Think about it. Does every member of the population have a chance of being selected? The answer is no. The football team is made up of boys. The girls would not have a fair chance of being selected. Let's try the next one. Would it be a fair and random sample if we surveyed 50 students in the first lunch group? And of course, the answer is no. The first lunch group is made up of 6th graders. The 7th, 8th, and 5th graders would not have a chance of being selected. So not every member could be chosen for the survey. How about number 3? Survey 50 students in band and orchestra. Well, once again, not every member of our population would be chosen or had the opportunity to be chosen. This would be a no. How about this? Would it be fair and random if we surveyed 50 students in the front of the building in the morning? Does every student have a chance of getting selected that attends Washington Middle School? The answer is no. Out front, we just have 7th and 8th graders. We would not have a chance to select any 5th graders or 6th graders because they're out back. So they're in the population, but they don't have a chance of being selected. So the answer is no, not a random sample. Take a look at the last two. What if we put all 500 names into a big barrel, mixed up the names, and selected 50 students to vote on the mascot? Well, as long as every student in our building had a chance of getting selected, then it would be fair and random. And last but not least, how about this technique? So we get a yes right here. This is a random sample. What if we put every student's name on an alphabetical list, all the 5th graders, 6th graders, 7th graders, and 8th graders, boys and girls, and selected every 12th student to vote on the mascot? So that means we would count from the top 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and select every 12th student. Would that be fair? Would every student have a chance of possibly being selected and surveyed? Well, the answer to that one is yes. That is called systematic surveying. And that would allow every student in the population to have the opportunity of being chosen. So you will take what you know now about random sampling and use it to answer questions on the following page. Remember, to be fair and random, every member of the population floating around in this rectangle must have the opportunity to be selected for the sample. That's what makes it fair and random and representative of the population. This concludes page 8.